I did using the radical function. Here's my f of x. This is what I'm actually trying to find.
I totally have it now.
Now, you'll recognize a lot of the formulas that we went through. This one here was to find the nodes. That's the same for all three methods. Delta x is here.
What is sigma?
A is x naught. B is x of n. I goes from 0 to n. If need be, for the midpoint rule, I'm going to take the average of the previous couple. We're going to find it that way. So I'm going to show you Simpson's rule. All right, let's look at trapezoidal since we just did it. So trapezoidal rule says I'm going to take 1/2 times delta x, which we figured out, actually, through logical progression. And you'll notice the first term, when I equals 0, and the last term, when I equals n, are just 1 times it. I'm adding up from I equals 1 to n minus 1, because this is n, right? So it's going to be n minus 1, and I'm going to double all of those. So this is sort of the ultimate form of the trapezoidal rule, as we hit that. Generalized. Anytime I see the summation sign, those of you who have done some computer programming, you see a for loop. That's what that is. You're starting in one place, you're doing adding, doing adding, doing adding, and then you're getting a total at the end. Okay? We'll talk about that in a bit. Trapezoidal rules, Simpson's rule is a little different. It looks like this in your book for the most part. The nodes are exactly the same. You're going to calculate them exactly using this, the same way we did before. Be it n starts at 4, be it n starts at 100, whatever. Here's Simpson's rule, and again, the derivation's in your book. This says it's going to be 1/3 times delta x. You can see in the book where the 1/3 comes from. The difference with this one, again, like the trapezoidal, the first term and the last term are left alone, as far as adding them up. However, the middle terms alternate. The first one, x of 1, you get a 4 times that. Next is 2, next is 4, 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 until we hit the last piece there, or second to last, I guess. The difference with Simpson's rule, n must be even. Otherwise, it's not going to end with a 4, and the rule won't work. And the derivation explains all that, as you go through that. So what I want us to do, again, we're using the nodes. So delta x is 1/4. And we have x naught is 1, x of 1 was what, 1 1/4, x of 2, 1 1/2, x of 3 is 1 3/4, x of 4 is 2. I want you to see if you can use Simpson's rule just by me handing you the rule. See if you can piece it together using these 5 data points.